Do electrons think? Electrons are charged particles, the minutest we find in analyzing the ultimate constitution of matter. To think that such a particle can think is so absurd that I might give the answer no and have my talk over. However, the idea has been launched not very long ago. Not, of course, in this patently absurd form, but under a disguise. Of late, it has off and on met with quite honorable reception. Some intellectual hope has been set on it. I wish to plead here for the futility of this hope. To explain matters, I must go far back. There's a very old dilemma in natural philosophy. Are our bodies and the bodies of the animals machines that act of necessity according to their material constitution and under the material influence of the environment, including the impressions on the sense organs? This question, are we automatons, has about as often been answered emphatically in the positive as in the negative. It would lead us too far to follow all the arguments that came to the fore in the long history of the controversy. Strange compromises were suggested. Descartes, for instance, deemed us to be, on the whole, automatons, only the pineal gland, he said, was not. According to Descartes, it was this organ which controlled and directed all our spontaneous bodily movements. What is the present attitude of physiology to the question? We may take for it the word of its past master, Sir Charles Sherrington. According to Sherrington, there is no boundary between the animate and the inanimate. The same laws of physics and physical chemistry hold within the living body as outside. The most careful investigation of the physiological processes in the nerves and in the brain reveals no leverage whereby mind could take direct influence on matter. Mind per se, that is, by its very nature, cannot play the piano. Mind per se cannot move a finger of a hand. This leaves us with the outlook that our body is as automatic or non-automatic as any inanimate piece of matter, any mechanical, chemical, electrical contrivance, only infinitely more complicated than even the most ingenious man-made machinery. The question is thus referred from the tribunal of physiology to that of physics and chemistry. But in the tribunal, to keep to the simile for a moment, there sits by the side of the judges a non-jurisprudent assessor, namely our own little self, which finds it distasteful to pass for an automaton. Now, what does physics say to it? The situation is peculiar. From the earliest beginnings of physical science, we meet with the firm conviction that everything that happens is governed by inviolable laws, so that the course of events forms an inevitable and unalterable infinite sequence of causes and effects. The first atomic physicist was Leucippus, a contemporary of Socrates in the 5th century BC. Of Leucippus, only two sayings are preserved. One, that he refused to believe that sun, moon, and stars are living beings, and the other, which concerns us here, is that nothing comes to pass without a cause, but everything happens by reason and of necessity. This he maintained in the 5th century BC, and towards the end of the 19th century AD, physicists were fully prepared to endorse his opinion. But now comes the peculiar thing. Twice, within 2,500 years, there was a notable departure from the belief in the strict necessity of physical events. The first time this happened only about 150 years after Leucippus. We gather this from the didactic poem of Lucretius, who was the posthumous mouthpiece of Epicurus, who lived in the 4th century BC. Their suggestion had no consequences. It was all but forgotten. The second time the strictly causal linkage in the chain of physical happenings was thrown into doubt was only 30 years ago by Franz Exner in Vienna. About 10 years later, that is about 20 years ago from today, the disbelief in strict causation became part and parcel of what you might call the new creed now adopted by most physicists and called quantum mechanics. Both times, the alleged breakdown of strict causality in the domain of physics was hailed for removing the obstacle in our understanding the spontaneity of the movements of the animals and of man, in understanding free will, as one usually calls it. Let us see whether this claim is justified. The hypothesis, as reported by Lucretius, was very simple indeed. He just states that the atoms do swerve in a very small but entirely undetermined and unforeseeable way from the courses you would expect them to take from supposed strict physical laws. No theory of the swerves is offered. This amounts to saying that the strict laws are only figments. The actual path of a particle is to a small extent arbitrary in the neighborhood of the fictitiously prescribed path. It is not illogical to surmise that the several little arbitrarinesses of the single atoms collaborate to bring about the apparent arbitrariness in the behavior of the animals and of man. What Lucretius forgets is that he has explained nothing. He has solved no problem. He has only referred the problem back to the ultimate particles, where it has become much more difficult to grapple with. The simplest spontaneous bodily movement, say the lifting of my arm, would require the planned collaboration of billions of single atoms in their undetermined swerves if they should bring about the integrated action. In modern physics, the denial of strict causation is of entirely different nature, in two respects. First, there is no question of only small departures from a fictitious exact law of motion. The behavior of primal particles, as electrons, for instance, or of small atomic systems composed of only a few of them, is now supposed to be undetermined and unforeseeable within a wide margin of uncertainty. It is thought that in times we have to allow a particle the choice between several entirely different courses to take. Let this for the moment be figurative speech, meaning only that nothing in the observed situation determines the course the particle actually takes. But on the other hand, the situation is supposed to determine with rigorous precision the statistics of the various possible choices. Given the same situation over and over again, the particle will, for instance, in exactly 2/3 of the cases follow one course, in 1/3 of the cases the other one. and similarly when there are more than two courses to follow. Again, the same as 2,000 years ago, it has been suggested that this breach of strict causation leaves room for the display of the spontaneous movements in the animals and in man. Is this claim now justified? I think not. There are grave objections from physics, from physiology, and from philosophy. From physics. If the individual, or its mind, or whatnot, could make free use of the choice left to the single electrons, this would infringe the statistical laws when a synoptic view of many similar cases is taken. This is as bad or as good as a breach of strictly causal laws. If we suspend physics in the living body, we can explain anything. I'll put this point briefly and drastically. It could be clinched in all detail. To explain the physiological objection, let me observe that physics strictly disallows a mutual dependence of the choices taken by various electrons unless they are close neighbors. One would therefore have to assume, and this has been proposed, a master cell, and within it a master molecule. And here the choice on the atomic scale would take place and would determine a spontaneous movement of the whole body. This is flatly contradicted by what we know about the functioning of the brain. The number of brain cells cooperating in such a case is enormous, and the idea that they should always be set at work by one master cell, even if it were not to be always the same one, is ludicrous. But assume you could override even this objection. There might be a delicate system of relay action which we may have hitherto failed to discover. Then I am left to believe that a single electron, or very few of them, by making use of the free choice the primitive laws of physics leave them, should enact a movement of my body. However, this movement is sometimes preceded by a long deliberation, a careful and maybe painful weighing of motives. This ultimately disposes, let me say, my mouth to open and to pronounce the name of a person I hesitated to give away. It is not only obvious, but actually indubitable, that the preliminary deliberations involve extended parts of the brain, billions and billions of cells. To assume that this activity eventually determines the decision in the supposed master group of electrons would entirely spoil the game. For the point was that their behavior was to be exempt from physical causation. If you want to keep this up, you needs must be prepared to let all the thinking and weighing of motives be done by the one master group of electrons alone, and without any accompanying physical process. This is absurd.